There are lots of particular types of sequences that exist. We're going to focus on just two of them in our class. So this lesson is going to focus on the arithmetic sequence. An arithmetic sequence is when you either add the same number from one term to the next or subtract the same number from one term to the next. So you have to know where to begin. Let's say you begin at the value 10. And let's say the definition says to add 3 each time. So from 10, you would go to 13, followed by 16, followed by 19, and then on from there. And so that's the definition of an arithmetic sequence. So once again, A sub 1 is going to be your first term, just like it was in the previous section. A sub 1 represents your first term. In order for this definition to be doable, you need to know where to begin. D is known as your common difference in your arithmetic sequence. And yes, we're using the word difference, but it could be the common sum. It's just the common amount that you either add or subtract to go from one term to the next. So don't think that it has to be a subtraction because I'm using the word difference. So to understand how the arithmetic sequence is constructed, consider the sequence where the first term, A1, I'm actually going to change this a little bit. I'm just going to say A1 equals A1, all right? That's where you start. And then the next term, which is A2, is where you take A1 and you add that common difference, D. A2 equals A1 plus D. If you wanted to write that as a formula involving the number of times the D has been added in, it would be A1 plus one of those Ds. A3 is going to be the previous term, A2, plus that D again. Okay, but remember A2 by definition is written as A1 plus one of the D's. And so therefore A3 is A1 plus two of the D's. And this pattern would continue for an arithmetic sequence. You just keep accumulating the number of common difference values you need to keep adding, all right? The first term had none of them. All right, so I guess you could have written out A1 plus 0D if you really wanted to have something in that position. The second term is A1 plus the first term plus one of the D's. A3 is A1 plus two of the D's, and this pattern would continue indefinitely. And the ending result would tell you that AN is equal to the previous term, so AN minus 1, plus a D again, where AN minus 1 already had a certain number of D's that you were adding together. So AN minus 1 accumulated the AN minus n minus 2 D's if you really want to get specific. So altogether, we have n minus 1 D's that we're adding to the first term to get to the nth term. Okay, so maybe we'll take this discussion right here a little bit further where we stopped. Let's go to the fourth term. So the fourth term would be whatever you had for the third term plus that common difference. And the third term would have been A1 plus 2 D's. Now you're adding an additional D for that next term. Altogether, you have A1 plus 3 D's. Let's do another one. The fifth term, A5, would be your fourth term plus an additional common difference value, but the fourth term was already A1 plus 3 D's, right? Because that's how it was defined right there. And so now you're adding an additional D to that to give you altogether A1 plus 4 of the D's, right? 3 D's plus 1 D gives you 4 D's. So now you're looking for this pattern to show itself so you understand how to write this in general. So they notice that the value that is here with the number of times you're adding in the common difference, D, is equivalent to 1 less than the term number in line that you are writing this down for. And so if you're looking for let's jump ahead a little bit. Let's do the eighth term. That would be the seventh term plus an additional D. But the seventh term already had A1 plus 6 D's. And so you're adding this additional D now to get to the eighth term. Altogether, you have A1 plus 7 of the D's. All right, so I think it will help if you put some numbers behind the context here to see how it actually works. But you're counting how many times you're adding in that common difference. And the number of times you're adding in the common difference is the value of n minus 1. Okay? In order to show, or in order to find, I should say, in order to find the nth term in your arithmetic sequence, you're going to use this formula. This warrants highlighting because we're going to use that quite a bit. Now that is also on your formula sheet under the 11.2 section of your formulas. And so just make sure you know where to find it when you need it. And then the next formula that is not on your formula sheet, but it probably should be, I would just go ahead and write it on there since you get to use your notes for the test and the final. You're going to show, oh, that's not what I wanted to do. Sorry. You are going to show that this is true in order to show that your sequence is arithmetic. Okay, so whenever you're asked to verify that your sequence is arithmetic, that is the quantity that you want to prove exists. And you'll see that in action in a couple of examples. Back to your formula sheet. If you're adding up the terms in an arithmetic sequence, right? You're constructing a series now since you're adding up the numbers together. The sum of n of those term values is equivalent to, I like this last version the best. It makes the most sense, okay? But if you're adding up the terms in an arithmetic sequence, remember how the general formula for an arithmetic sequence we just talked about is right here. And I'm using the variable k now instead of n because I'm allowing that term value to change, right? So the first iteration through of my arithmetic sequence, k would be 1, okay? And in that sense, I would just get a1 for my complete expression. The second term is where k equals 2, and so that would be a1 plus 1d. If k equals 3, that's the third term, so that would be a1 plus 2d, and so on and so forth. And when you expand it out, you get to this line right here, but the final version that we like to use to calculate the sum of all n of these terms is on that last line. All right, here we go. Example number 10, show that your sequence is arithmetic. So if you look back up where it's at the top of the screen right now, to show that it's arithmetic, we want to show that an minus 1 equals d. So I'm going to jot that down. Show that an minus the previous term equals that common difference d. So that makes sense if you understand that in order to get that an term, I would take the previous term and add a d to that. So just rearranging those three pieces gets you to what we've already learned from the beginning of the section. Okay, so this is how I'm going to show that my series, my sequence, I'm not adding them up, my sequence is arithmetic. Okay, and so you're told that the nth term in your sequence is going to take on the form of 4 minus 2n. So 4 minus 2n is my nth term. Now, I want to subtract from that my n minus 1th term, right? So you're going to substitute n minus 1 in place of the value of n. It's kind of like a function, all right? Sequences are functions, and so you're replacing the input value, which is n, with the new input value of n minus 1. That goes in right there, all right? So that's going to look like 4 minus 2, now the new input value, n minus 1. And you're going to work this out, expand it, simplify it, like terms, all that stuff, and see where it takes you. So if I work inside the second group of parentheses, I would distribute the negative 2, so to get negative 2n, and then plus 2, and keep on going. Inside those parentheses, 4 plus 2 is 6. Keep on going, distribute this negative sign right now. So negative 6 plus 2n is what you've got. Now the n terms cancel out. And that's what you want to have happen. When you're proving that your sequence is arithmetic, you want those n terms to go away, leaving you with a constant. And that constant is that common difference. Okay, so that's a verifying or a way to verify that your sequence is arithmetic, or to prove that it's arithmetic, or even just to see if it is, right? Maybe we didn't know that it was going to be arithmetic. Well, this shows you that it is, and the common difference is equal to negative 2. So that was the first part of this question. The second part says find the common difference. Done, just got it. And now we want to write out the first 4 terms. So the first term is where n equals 1. 4 minus 2 times 1 equals 2. And the second term, well, the second term should be 2 smaller than that, right? because my common difference is negative 2. So I should be subtracting 2 to the next term, but let's make sure. 4 minus 2 times, what am I doing? 4 minus 2 times 2, second term, equals 4 minus 4, and that's 0. Now the third term, I'm going to guess, is negative 2, because I should be subtracting 2 each time. So I get 4 minus 2 times the third term is 4 minus 6, and that's negative 2. And the fourth term that you were asked to write out, 4 minus 2 times 4, should be negative 4, right? 4 minus 8, sure enough, is negative 4. You see that you're subtracting 2 each time. So the first 4 terms of my sequence are 2, comma, 0, negative 2, negative 4, keep on going. We don't know where to stop. For 16, you're asked to find the nth term of the arithmetic sequence. And what is the 51st term? Right, so you don't have a formula yet, but we're going to come up with the formula because you're told the sequence is arithmetic. That's good to know. You're told where to start. A1, the first term is equal to the value 2. The common difference, D, is equal to 3. So there's a formula up above, and it shows you that the nth term is written as, right there, an is equal to a1 plus n minus 1 times d. And that's on your formula sheet. And now is a good time to go ahead and use that. The first term plus n minus 1 of those d's. Right. We know the value of a1. We know that that's going to start us at 2. I don't know n, but I do know that d is equal to 3. All right, so I'm just going to write out the general formula, which is what? 2 plus 3n minus 3, or how about negative 1 plus 3 times n. Now that's a formula for the nth term. Okay, that is for the nth term. I want to know what the 51st term is going to be. Therefore, A51 is going to be negative 1 plus 3 times 51, and 153. Negative 1 plus 53. How about 152? All right, this is not a sum. This is not the sum of the 51 terms. This is the actual value of the 51st term. So the long way of getting this answer would be to start with the number 2 and then keep adding 3 each time. So you got 2 and then 5 and then, what am I adding? 3? 8, 11, 17, 20, 23, 26, dot, dot, dot. You do this until you get to the 51st term, and hopefully that's 152.